Good morning. Thank you for your interest to listen this contribution on the topic of children's obesity. Some years ago, when I was invited to participate in this topic, which is not the regular one in my work group, it seemed to me a new topic, because some years ago we didn't have this clear image that we now have about this great problem of our country. And as a physician and biochemist, I found it very relevant to insert this in the analysis of obesity, metabolic syndrome, diabetes, specifically in this population. And what the reason for the development of this work line is something I must recognize from the very beginning. In fact, this was my first response to the analysis of the problem. What we are going to discover is, look, water. We know from the literature that there is a great deal of information that relates the benefits of exercise at any age, at any level. And, well, this was part of what caused the development of this work, with the purpose of applying our knowledge. What I will tell you about the work that we have finished is precisely how we compiled everything for this to be useful. It is something that goes beyond what is strictly academic, that with the intention of applying what we learn and what we know. We have the starting point, obesity and overweight in our country and what they represent. You know very well. I'll only repeat this to present the logic we followed in our work. We know from our last national survey that the prevalence of obesity and overweight added up in children is of around 32%. So this means that the ratio is very high. It has been a surprise to find this high prevalence. And it has to do with the numbers in adults, which are really terrible. Yesterday, our first speakers mentioned the great consequences this has. And the problem is something that we must contemplate in the context of our country. We know that our population pyramid is full of young population. And that is why, aside from having a serious problem, it's also extraordinarily common in our country. What motivated us to develop this work is precisely the lack of initiatives geared towards the palliation or remediation of the problem. It's a complex situation. What we show as an opportunity, window of opportunity, is what we have in this transition. We have more or less 10 years to prevent this prevalence from becoming this terrible numbers. This was a window at the beginning of the decision making. We'll try to counteract this sequence that ultimately leads to diabetes, and knowing in advance that obesity is an extraordinarily complex phenomenon to explain. We had to tackle this somehow. And yesterday mention was made about how the conditions surrounding our population have indeed facilitated the development of obesity. And we also add up this genetic background that characterizes us. That is why our population is not only more prone to develop obesity, but also to develop comorbidities that accompany obesity. So the decision is, let's do something. And the proposal was precisely to try to modify this, meaning to introduce a variable. While we tried to solve this, we could start having a benefit. So that was the purpose of our work. We were analyzing this. Yesterday, Dr. Musafari mentioned that diet could be improved. But, well, we must recognize that this has to be adapted to our own population. To bring nuts and salmon to our population as the ideal food is something unthinkable. But we have to do more work to tackle these problems, to cope with these problems, and to find ways for the balance to be modified in modifying some of these variables that are extraordinarily complex. So in order to carry out an intervention, and the message is that the very first thing we did was to implement or coordinate several working groups to comply with these commitments. We wanted to establish an alliance. This is an experiment in itself, because in Mexico we are just not used to having this kind of alliances. We have multiple difficulties to gather the academic, government, and private sectors. This was, of course, a highly desirable goal. The objective was to implement and, above all, to assess. The evaluation, the assessment of this kind of interventions is something we badly need. We need to give the decision makers inputs for them to consider that the program, the intervention can be useful. It's not only a matter of wanting to deliver a strategy, but also to validate the results. Looking for the replicability of these programs. And of course, as a consequence, to start to develop a research line in the area of children's obesity that has been poorly represented in the academic community of our country. I must be very clear. This requires of many opinions and different experiences. The protocol we developed is one that involves at least all these groups in a formal way, each one contributing with different elements, coordinated from the School of Medicine. This is already an initiative of the National University of the Children's Obesity Program, and we're working them to develop in a more logical and complete way with the participation of other entities of the National University to better understand and to develop new alternatives along these work line. But what I will tell you is precisely that we need to join efforts coming from all the people working in these institutions. Just for you to have an idea about the sequence we followed and the time invested at the management level for this to be a replicable phenomenon, we went through all this sequence. We discussed this with the officials and the authorities of the Ministry of Education in the state of Mexico. They are very interested in developing programs to palliate the problem. We discussed this also with the principals of the school, with professors of physical education. This is a group of professors that fortunately gave definite thrust for this to happen. Without them, it wouldn't have been possible. And the professors themselves trained the school teachers at the classroom and discussing this with the scholars. This took us much longer than the project itself had expected. What did we do? Our program approached 49 schools located in different sites of the state of Mexico, and this involved, well, most of them were urban and suburban schools, but there were also some schools from the rural areas with 20,000 students. We are going to do this in such a way that it can look more similar to reality, closer to reality. We involved 49 schools. This is the estimate number of students, slightly more than 20,000. And we introduced a routine with the following characteristics: 30 minutes every day during all the school cycle within the class schedule. I emphasize this because one intention is that these kind of activations should be part of the daily life of children and of the school community as a whole. The school children and their families, for them to become used that the sequence of activities at school, aside from math, Spanish, and other subject matters, it's also physical exercise. The proposal was then to develop a program inside the schools without any other technological requirements, meaning there was no music required, spectacular exercises, and there were just simple routines that the professors developed from the Ministry of Health. They developed routines that could be applied in different age groups. We had 3 different levels, and weekly rotations were possible for them to have a variation and thus not having professors or students that were bored. This was to expedite the intervention. What we were looking for in more formal terms was to increase the heart rate more or less at 75%. They were never extenuating or pressing or stressing efforts, but every day, always. Irrespective of the weather, this was done in all schools. In order to evaluate them, we chose 5 schools. There were around 1,800 children. And here it is where the teams of the National University participated for the direct follow-up of the impact of the program of intervention in these variables that I show here. Anthropometry, blood chemistry, blood pressure, and metabolomic changes. This is along the way of integrating a work line that is more robust and sounder. And these are the results. We intervened in the follow-up and the validation of the effects of this program. 1,888 children. These were children that we saw both before and after the intervention. We carried out a baseline assessment and another one at the end of the school cycle that coincided with the end of our intervention. We were around 7 months developing this on a daily basis, and we gave a very close follow-up. The PE professors helped us a lot to check that this was really happening, and the numbers slightly exceed 85%, but I present this as a reference information of the school where we reported the lowest compliance. It was always over this number, which means that we were very successful in implementing it. The children, let me share this with you. It was a great scene to see how they were walking to go to the facilities. They found the way to be able to go to all classrooms in spite of some limitations in some schools that have always been a problem to develop programs of physical activation. And we found the following: overweight and obesity prevalence in this population, and I'll give you the population data. At some point, there were specific references to a certain stratum, but I'll concentrate on the general data. The prevalence is practically identical to the one we have in Ensanut, 33% of overweight and obesity. Adding this up, we didn't find any significant difference in the distribution by girls or boys, and we fortunately found very few cases where there was malnutrition. These are data that we assessed using the most common charts that have been adopted worldwide for this kind of population. I want to call your attention to this piece of information. When we separated the findings I just showed by age and gender, we find something that was a real surprise to us. It's quite unfortunate. In girls and in boys, there are variations by age, oscillations. We don't know the reason for this kind of oscillation, and if you see here, boys have a slightly higher trend as years go by during grammar school. But what is really dramatic is this piece of information, 30% and 30%, meaning they are entering the grammar school with the same prevalence that they will have the rest of the season as a prevalence of obesity and overweight. So the bad news is that we are arriving late. We are coming late. They come to school already having the problem, and to be very sincere, we didn't expect this. When you see the data, I don't know if you can see them, but it is around 10%, the national prevalence in children under 5 years of age of overweight and obesity. This is something that amazed us, because Ensanud reports 10% prevalence in children under 5 years of age. Evidently, all the ages are mixed here, but it is like quite a quantic jump of this 5% that we are identifying in our population, meaning the sector, and this is a first conclusion that I find very valuable to what we are going to continue doing, is the sector where we have to intervene. It is the one before 6 years of age. We have to see what is going on in our country regarding children under this age. So this leads me to some concepts we already heard yesterday related to what we have to learn since the gestation. This is fortunate because this takes me to the work lines that we have cultivated in our group, human pregnancy. And there's no doubt that we all have to concentrate on the understanding of these interrelations that happen during fetal programming of growth of individuals. This is something that in our countries unknown. We don't have anything at all. We are barely, some groups starting to do this, but it sets the beginning of the analysis we must conduct to understand why we are getting at 60 years of age with 30% of obesity and overweight rates. This is an enormous, huge job, and we expect to see results soon. More information about the baseline status. I would like to highlight this. This overweight and obesity is already manifested, and this is not new. It appeared in this first publication done in 2005 with school-age children, and you already see the effects on blood pressure, meaning there are children with pre-hypertension and even children with arterial hypertension at this age group, 6 to 10 years of age. It is inadmissible. It's totally inadmissible. We cannot wait any longer to develop programs to tackle this condition. We know very well that high blood pressure is a serious health problem. We are finding also a 35% prevalence of glucose concentrations over those recommended. This is already corrected for the population we are analyzing. We are using international criteria for the classification based on our population. And you can see here 35%, 38% who have triglycerols elevated in blood. We are having high concentrations of LDL and a proportion that is very important of HDL below those that are recommended for these populations. It's very clear. Our panorama totally justifies an intervention. What happened after these 7 months of physical activation? The findings, and let me stress this, from the anthropometry standpoint, no differences were found. In doing all the calculations, considering the time that went by, the growth of the children, the gender, etc., we did not find any impact at all that could be measured in the body mass index. This agrees with a great deal of what the international publications say when they claim that to publish an indicator as the abdominal circumference or the body mass index, other interventions are necessary that have to be long-lasting. And let me take advantage of this first result to say that the body mass index as used is an anthropometric measure that really does not tell a lot. It's not that it is bad. It has been used and it will be continued to use, but the body mass index does not differentiate this linebacker from Mr. Michelin. There's no way for us in our practice to use this concept. And I'm emphasizing this because a great deal of where we should be going, and that's part of our proposal, is the search for new markers that will allow us to better understand what is going on, not only in obesity as a condition, but also in the mechanisms, on the underlying mechanisms. Something important is that we were able to correct a very slow proportion in those already having high blood pressure. Of course, all the children were referred to care centers for their surveillance, in whom we found these problems, and these are the collaborations that the state of Mexico's government provided us. In these children who were detected having this, they were referred to the right places. But there's susceptibility to improve pre-hypertension. 24% of children who were diagnosed as pre-hypertensive could correct their values, and in population terms, diastolic blood pressure precisely marked the difference. It is a reduction that was highly significant. You can see what happened with glucose. Glucose was corrected in 35%, am I right? Starting from 35, we went down to 19%, which is something that encourages us a lot, because finally, even though the BMI data were not modified, we started to see a totally different panorama when we started to approach the biochemical markers. Definitely, if half of the children normalized their serum glucose, this speaks about the success of the program. This is also seen in other markers. LDL that was reduced, total cholesterol that was reduced, triglycerides reduced, and what I mentioned before. All of them probably discretely, but all of them significantly at the population level. We would still need to analyze some details by strata. Taking advantage of the development of this project, I will show you our results in the metabolomic study. This is one of the consequences of the strategic alliance that the School of Medicine has with the National Institute of Genomic Medicine, which has given us access to these methodologies that allows us to analyze for the first time, which is also something unknown in our country. For the very first time, we see the perspective of metabolism in a comprehensive way. To be able to see the metabolism functioning at the same time is something that biochemists, as myself, did not learn. We are now starting to learn how to interpret this new aspect derived from the metabolome situation. I'll present the results we have with regards to the serum amino acid profile and acylcarnitines in these children before and after the intervention. Acylcarnitines is one of the newest markers, still controversial. We are still learning about its usefulness, but they have been established as a marker because there's enough information to know that the so-called acylcarnitines, up to some time ago, we considered that there was no circulating acylcarnitine, that it is false. Once the fatty acids have been attached to carnitine, for their transportation to the mitochondria, where this takes place, they can go out of the cell. They can go out and they can be exported. There are even exportation mechanisms that are devoted to this purpose, and they circulate at very low concentrations, some of them. Others can be considerable, as this AC2, which is one of the most abundant ones, is in appreciable amounts. But here I'm showing with AC2, I can present this clearly as an example. This is the AC2 concentration in children before the program, and this one is after the program. And this is really dramatic. The change is really extraordinary, and it precisely reflects the metabolism that is modifying. Is being modified, and specifically, even though AC2 can come from the classical beta oxidation, it's fundamentally derived from the use of amino acids. So this indicates that the amino acids that were used by the children before the program was installed is significantly reduced in its way towards the formation of acyl carnitine. The other ones that more directly reflect fatty acids are also modified. AC16, palmitoyl carnitine, that would be the most abundant component of fatty acids, is significantly reduced together with what we had seen in triacyl glycerols. So it is giving results represented by a component analysis. We are becoming more and more familiar with this kind of representations. Here you see the main components, C3, C4, C10, C8, that are the ones that move more. This is at the population and the way they are modified after exercising. It's very clear how they are being modified. A way to interpret these charts is that starting with the scattering of the population, we face that after exercising, there are many more options for the metabolism. This is a simplistic way of presenting the information, but finally you see how it definitely changes the behavior. It is totally different with this intervention. Something we think about its usefulness is that we are identifying a proportion of children close to 10% who are non-responders to this maneuver. They might be just a group of children who do not like to exercise. That we don't know. But it takes us to the analysis of a problem where we could indeed, using this kind of methodologies, identify children that are susceptible and the ones that are not susceptible, especially to the intervention, so that we could focus the efforts, and also to include other aspects as genomic markers. Amino acids move in a similar way. Probably it's less dramatic in terms of the main components, but of course they are clearly reduced. This is what I meant a while ago. This is the behavior, the way to behave in terms of dispersion or scattering of the populations. Precisely the possibilities opening. We now have mobilization of children in terms of groups, and these are broader options of the use of metabolites. What do we have? What we have is that we are showing that even though we do not see changes that are anthropometric changes, we do see huge metabolic changes. Without trying to biochemically link this, I nonetheless show this just for you to see that all the findings are beneficial in the management of these children. There's less glycemia, there's a reduction of circulating fatty acids because of this gluconeogenesis is reduced, which for sure contributes to glycemia. Beta oxidation is reduced. The use of ketogenic amino acids is reduced, and also the production of some of these acylcarnitine species that cause insulin resistance. So, why repeating this? It could be too technical in terms of the use of a program of this nature, but this is to show you that the decision makers should consider that there is extraordinary benefit from a relatively simple intervention. This also leads us to question if we are at the threshold of identifying new versions of phenotype. So far, and by this I mean that the paradigm is that the BMI 30 or 25 BMI as the most common markers. We need to add to this the complexity around the individuals. If we add, as I just showed, BMIs that are identifiable as overweight and obesity, but if we make them exercise from the metabolic standpoint, we introduce a series of variables that for sure will modify the clinical prognosis of these children. And this is precisely what we want to see happening. There's no doubt that we have to take care of obesity and overweight, but if we are not successful totally, we have to give the benefit for the phenotypes. There is a great deal of literature saying that the limits currently used for BMI combined with other conditions as exercise cannot be harmful. It's worthwhile, I believe, to explore these ideas even further. We've been able to design a program of physical activation that we launched in the state of Mexico in a successful way. We were able to consolidate the ideas and the perspectives prevailing in sectors we are usually not engaged with, and we are delivering to the state of Mexico and eventually to other agencies a replicable model that can happen in the school environment. This is a numerous team. Before, well, I realized that some people were missing, but there's a huge list of all the people helping and participating. Edith Yanes is not mentioned here. She was the modulator of the training that all the nutritionists received in the standardization of the measurements, because of course we did this as careful as possible. Thank you.